record this one. Yeah, then if we get back to this one for a certain reason, I want to go back to this one again because that related to the homework is that sometimes we can set up in two ways. One way ANOVA, one MANOVA actually, the multivariate analysis of variance. One way and two way, both ways we're going to do that one. To get a clear idea about that one, let's little bit go through this one real quick, just real fast, and then we can go to the homework and then go back and forth. Even tomorrow we have plenty of time to finish everything, wrap up. Look at that. If you come back to this one, I did some kind of a changes over here. See, now I'm going to call that on one factor. One factor means just you have only not the variable. I'm not talking about the variable. I'm telling the factors. Okay. Under the factor, you have one variable here and one group. See, three things you have to take into account in this scenario. In this case, you have a factor, you have a classes within the factor. Factor can be that split into classes. Like let's say factor, you're going to say gender. Gender can be classified into two classes, male, female. The income you can classify it high income, medium income, low income. At the same time, variable also would be the same thing, but variable gonna be different thing down the road. That's why I'm trying to clearly mention you have a factor, group, variable. These three, please have a kind of like a distinguish among themselves and then get a clear idea about it. In the first place, we think that we have one variable, bottom line, one variable, or one class, or one factor. If that's the case, in order to run that one, but I need I want you guys to write the model related to this scenario. What's the model actually? When we write something that this doesn't make any sense, where's the model? Yeah, what we are trying to talk about over here. We just simply say, okay, you have to estimate this guy versus this guy, or that test mu equals mu naught versus its counterpart. That's not what we that's true that we need that one, but before that, what we really need to have is the model related to this one. You can remember in NANA 605, 600, we talk about the empty model related to this one. You're going to have an empty model. Why I'm telling like that? Because look at that. If you write the model is the key part here. Okay, the model playing a key part. Look at, you have a here. See, there's nothing on this axis. Can you remember empty model? No, nothing on that x-axis. No, nothing on x-axis. You can remember. And on this one, you have y all the time. I used to do this one. See, that's the response. That's what we are interested in. We are taking all the observation or the readings on y. We have one factor, see, one factor, and one variable, one factor, one level. Because of that, see, you have all the readings like this. See? Whose readings? Y's reading. Okay. So those readings, since you have one, I can say yi. See, this one, this for that one. These are the see. Or if you want to make it clear, you can say j. J indicate that j gonna go from how many observations? See, in observation in this scenario. This one, if you want to write as a model, how could you gonna write a model? For this one, you can definitely find something called the grand mean. Can you remember? You can find the grand mean, see, y bar, grand mean. Or you can simply say the mean. In this scenario, you don't have to say grand, you can simply say mean, grand mean, or overall mean. You don't have to say overall mean, or simply mean. Okay? Y bar. Okay? Y bar. Can you write that one? See? Can you write my yi? See, if you take a reading, see, if you take a reading from that one, see how it looks like. See, you can say my yi is the grand mean plus something. See, grand mean is this one. Plus what? See, this length. Let's say I'm interested in this point at this moment. Let's say any observation, that point, that difference. yi minus y bar. See, yi minus y bar in another way. Yi minus y bar. See, plus, see, that 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 error, that difference is called what? Can you remember? We used to call that one because if you're gonna measure that one, yi can be expressed as a y bar plus what? Error. Error. This one is nothing but the error. See? That's the error in this case. For the icon. See? Error. See? It's a grand mean. Can you remember? This is the empty model. Empty model. That's the one that we maneuver and then get the sum of squared treatment, sum of squared within, sum of squared cross product, everything we're gonna get based on this one. Okay, this is the key part. You have to always write the model. You have to always write the model. See, in this case, see, your yi is nothing but this one plus this one, which is the error. See, that's the model. See, so this is the model. This is the model. See, this is the model in this case. See, it's the empty model. See, so in a similar fashion, that then you have that one. In addition to you have model where the mu comes into the picture. Now you might be thinking where the mu comes into the picture. This is related to this one. This is a sample version. Sample version. See, this is a sample version. Its counterpart, population version we have. There's nothing on the x-axis. Again, you have a y, you have one variable. You have here, see, all the readings. I'm going to say yi, but this time it's not that one, it's mu. It's again the grand mean. Grand mean. Grand know that overall mean, but this one is population version. If you write this one yi, you can say mu plus epsilon I. This one I'm going to call that one epsilon. See? This one means. That's the model. That's the model. See, it's the empty model again. Empty model. When you have an empty model, you can do several things. You can unknown term. This is unknown. See, this guy is unknown. Grand mean is unknown. You are really interested in estimate. This would be a good estimate for that guy. See, that's an estimate. That's a one thing you can do that one. Your unknown mu will be estimated. You found that sample mean would be the good estimate. And not only that one, you can build up the confidence interval. You are not interested in one sample that estimator. You need a whole bunch of estimators for the confidence interval. We had that discussion too in a class. But this one, you testing. That's a third one. That under that statistical inference, you can remember statistical inference have two parts mainly. One is the estimation of unknown parameters. Okay, those are called parameters. Parameters in this case, in our example, is mu. Parameters. The other one, testing of hypothesis. Testing of the unknown parameter. See? In example here, H naught, you're going to hypothesize mu equal to something versus its counterpart, mu not equals to mu naught. But we have several cases like that, not only the not equals, greater than, less than, like that, but for our convenience, we're going to stick to only one version. In that way, we can build up the knowledge. Once you build up the knowledge, that can be extended to the other cases as well. And this one, getting in two parts. One is point, the other one is interval estimation. In a point estimation, as an example, what would be the good estimate for this one? Estimate, we're going to say hat y bar, sample mean. See? Sample mean. Not only that, and I need the confidence interval for me. That's about how you're going to get it. You're going to get the y bar plus or minus standard error. You can remember standard error you built up based on that different I'm sorry, not the standard error, maximum margin of error. I'm sorry, margin of error, MOE, margin of error. Margin of error is two parts of that critical value times standard error. That means standard error is nothing but standard deviation of y bar. Remember, that's it. That's how we built up. So this part we did. This part we did. This part is the one we are focusing on now, testing. For who will be tested? The unknown parameter available in our model. Okay, an unknown parameter available in our model. That's the part that we are testing in that case. Can you do this one? This in univariate case. In multivariate case, what's going to happen? Multivariate case, in order to run that test, you built up this t. You need a t. T would be like that. That t would be like this. We had that discussion. Then you t square. Then this become f. See, you know that one. But this is not what we are interested in. We are interested in the multivariate. In multivariate, we have a more than one variable. More than one variable. Here only one variable. One factor, one group class, but one variable. Here, more than one variable at the same time we tackle. That's for this one. For same thing, we have only one class. Again, you can build up, but here you have so many that the variables. See, this variable not only for y, maybe y1, y2, y3. I'm talking about the response variable. Okay, I'm not talking about this guy. Remember, we are not interested in this one. This is not the case that we tackle. We tackle the response variable. When response variable has like more than two variables, that's called the multivariate, not for the regressive variable, not here. This one. Instead of that one response, now you can add the several response for that case, but still you have one group. If that's the case, we use this one. See, I clearly mentioned over here, you can work with the t squared or you can work with f. Either way, see, that's what we were having too. Either work with this one or work with this one. How to make the conclusion at the end of the day? Very easy. When you have a test, in order to get that is done, you're going to look into the p-value or you're going to compare this observed value with the critical value of its counterpart. See, critical value or p-value. Go to the p-value and say that whether it's going to be less than 0.05. Then you reject h naught and make an inference. Okay. They say that somebody say that speed in that fine would be like $150. The police department say $150, and then some people claim and say no, it would not be. See, you collect data. See, collect data, and then we're gonna hire somebody to get this check. And then if you reject this one, then you have to accept this one, and then based on that one, then make the conclusion based on the given scenario. But in the multivariate case, even I'm not interested in this one either, single one. That's what I want to emphasize over here, but I get a rough idea over here that the same setup over here we utilize. Since you have that note, you can have a look at it and compare and contrast. See, you can work with f instead of t squared. We don't have a t in multivariate case. We have a t squared. Either t squared, you work with this one, or work with this one, or f. Okay, then you're going to compare f with the critical value or p value. In this example, we talk about the last time, see, variable 1 and 2, we're going to talk about the same time, see, tackle at the same time, see, not only one, see, 6, 10, 8. Like in this picture, see, if you have a 1, you have a 6, 10, 8, 6, 10, 8, only one variable. For other variable also, you have to have a look at it at the same time, see, 9, 6, 3, see, observation 1. Once you observe on that particular student, test 1, test 2, or that income and GPA or some information, see, like that, two variable only. I'm not talking about the groups. I'm not talking about the classes. I'm not talking about the factors. There's no that case at this stage. Okay, this one we did this one by hand. I did that one too. We can have a look at it how that can be built up. Okay, simply see all the steps. I didn't skip anything. We have this one. Now this one, once you get to this point, if you want to use that SAS, To get this done using MANOVA, you have to get the difference. You know that one. That discussion, we had that one in repeated measures as well. See, look at what I'm doing here. I get the difference of the readings. See, 6 minus 9, 10 minus 6, 8 minus 3. Okay, 6 minus 9. See, I'm getting different. 10 minus 6, 10 minus 6. That's how you're going to fit in into the multivariate case. See? When you get the differences between the adjacent levels, since you don't have a too many levels, see, you can simply get the adjacent means like sorry, you can get the differences between the variable, not the groups. Variables. I'm still on variables. See, difference between the variable, not the difference between the groups, not the levels, not the groups, not the factors. Okay, we're going to come to that one later on systematically. So I got the difference. That difference you call the D. That D has, see, the model has nothing on the other side, no group. It's not, there's no group on that side. And you have to use the intercept. And then see, since we have one variable, I'm sorry, this is not C, this should be D. This should be D. I used the C earlier and then I changed it. D. We can use the univariate T square as well. See? We have one variable D. We can use the univariate T square. We built up those two pieces and plug in into this one. See? You get this one. This one having exact and H0 of distribution with degrees of freedom. See? If you go ahead and run this one, see? When you run this one, see? We did that one last time. See? If you run this one, see? One way, one factor, MANOVA, one factor is Z, one groups class, same thing. Okay. One factor, one group class, or one group of class having original two variables. Okay. Original two variables. Originally you have a two variables. See? By one in the class. So we have to double check and see. 0.63. See? F value 0.63 degrees of freedom and those things. If you're gonna get this one, thinking that you can use the T squared for that difference. Okay, difference. I'm talking about the difference. Same thing that I did for the univariate case here. Sorry, here, here, see here, multivariate case, single multivariate case. The same way you can tackle that one. Then you keep going. Then 19/3. And if you get this value, I'm telling you, look at what's gonna happen. Okay. Look at, if you need the F value from this one, okay, from this one, look at here, from this one, if you try to get the F value from this one, you have a T squared. T squared is how much? 7/9. Should be multiplied. 2 and 1, that's okay. It's consistent with that one. See, it's consistent. Degrees of freedom, see, 1 and 2. See, degrees of freedom, see, 1 and 2. Here, look at degrees of freedom. See, 1 and 2. Here, degrees of freedom, what? 2 and 1. See, look at what happened. Then if you just treat as it is, see, the way that it has as a univariate, sorry, multivariate case, by with the aid of this theory, this setup as it is, see, you're gonna come up with this one. See the difference, 2 and 1. And then if you get the F from this one, it's not consistent with what you see from this table. Okay, here, even you get the put the data and then run that one, it doesn't consistent. See, so here I get the difference. See? Difference, and then I ran that one with the aid of that proc GLM and MANOVA, and I use the intercept. I'm gonna print E and H. You know, E and H means SS sum of squared array and sum of squared block. So sorry, sum of squared between. See, look at that one. When you simplify, 1 and 2, 0.6316. Excuse me. See, consistent with what we see here. 1 and 2. Each lambda is same as that one. We know that discussion. Yes. And H naught with the degrees of freedom, this one. Method 1, if you want to convert this to t squared, you can plug in the value. See, p equals how much? See? P equals, see, p equals number of variables. Transform data. Sorry, this one. Transform data. You have only one variable. One, not two. See? Okay. Either you use this formula. See, method 1. See, or use this formula. See, we had another formula. When you use a number of groups in the original data, see, you use this formula, but you use, see, G, see, number of group in the original, okay? So, see, so it should be, see, see. Actually, I prefer to say number of variables was, okay, number of variables in the original data, okay? Number of variables in the transform variable 1, number of variables in this one is G. That's true. See, okay. P is P for the transform one, this one for that one. Okay. Number of observation 3, that's okay. Then it is consistency. You get this one. And t squared, there's nothing to be multiplied by that one because we are dealing with only one, not the one variable. You are dealing with two variables. You are dealing with one group, one class, one factor. Okay, that's the reason. Then I'm going to go to the one factor, but one factor. Now you have a two groups. See, two groups. See? The univariate case, we talk about that one in large scale. See, now not only mu1, mu2, two groups. Okay, you have a two classes, one factor within the class, within the factor, gender. See, that's the factor. What are the two groups? Male, female. Okay, and age groups. We can categorize that numbers into that one. See? But one variable per group. You have one variable. Okay, it's a one variable case. Univariate means one variable. Univariate variable means one variable. See, look at here. One factor, two groups per factor, and variable, one variable per class. One variable. What's the variable? Say that salaries. Okay, the factor. See, factor and the variable pretty much the same thing in this case. See, this case. See, one factor and one variable, the same thing. See? Variable. You're going to check that the salaries of the male and female, and you're going to check the salaries of the people at the different age groups, and we're going to check that salaries at the different people at the different income groups, okay? Groups, classes. So if that's the case, two groups only, two groups, you do like this. We had a dependent one, we had an independent discussion. You have all the formulas, you know how to do that one in SAS as well. Okay, see? This one, then we get to that pool one is the most important one. We talk about that one. Then we went to the counterpart. Then this one, you have a more than one variable per group. For the group, you have a two variables. More than one. Sorry, not the two variable, more than one variable. That's why they become factor, the vectors. But still you have what? Still you have one factor, two groups. Two groups. In each group, you have two variables to be tackled. Okay, two variables to be tackled. See, that's the multivariate case is the one that I'm really interested in. For that one, dependent one, they say take the difference and then you can use this one, this formula. Independent, you use this formula. Okay. See, that's the kind of like an example. See, there's a fictitious data shown next to represent the scores on two measures of the council effectiveness, client satisfaction, and client acceptance. CSA and CSA. Six participants. N would be six. So originally randomly assigned to say counselors who used either behavior modification or cognitive method. However, they are in the behavior modification group are unable to continue for reason unrelated to treatment. For that case, see, look at that one. You have a group, you have a group two. See, you have a group two. See. So you have a two variables. What are the variables? See, these are the two groups. Two groups talking about here. Talking about here. You are still under one factor. You don't have a two factors. Sorry, here, see. Two groups. Focus on this one. See. Two groups. In our case, multivariate case, two groups. Sorry, here. Two groups and more than one per group. More than one per group. See. You have a two groups. See. Two groups, two classes. This is a class, but one factor. See. Under one factor. You don't use the under one factor. See. Under one factor, you can say that's this one. That factor, you can say that some method, okay? See, some method or something like that. See. Behavioral method, you use the behavioral modification and cognitive. See. This. And per group, you have a two variables, not one variable. These are variables. See, those are what? These are what? This is another variable. Same variable appear here, same variable appear here. Still you have one factor. Two groups. You compare these two. When you're going to compare these two, at the end of the day, you can compare these two too as well. See? You can take into account. See? Cognitive Y1 with the SA from the behavioral modification can be even contrasted with that of the cognitive method. See? And so that's with this. But we overall picture will be tackled at the same time. See, the H naught would be what? There are no mean differences between the behavior modification and cognitive groups. They both, when they are comparing simultaneous on the client satisfaction and client self-service, both in the overall this one, this average, this group average, and this group average, they were the same. See? For the group one, we use that one, this within the formula. See, using certain method, we calculated this one. You can remember the other day. Method two, you can calculate that W. See, sum of squared within this one. See? If you see, we have a two variable, but related to that one, here, I'm going to go back to this one before that one to get like a graphical, have a graphical representation on this one, little bit get a clear. Think about this one. Univariate case, you have one variable, one factor, one variable, but you have two groups. What that means, see? Like this, see? So see, we still have this one, see? Look at. So you have this one, Y would be what? Now you have what? Now they have systematically entered the factor. Factor has been entered. See, let's say gender. See, the factor has been entered. See, one factor. See? One factor, but two groups, classes, but one variable. You taking into account one variable. I'm talking about the response. Look at that one. This agenda would be my factor. See? factor. It has two levels, female and male. See, you can remember. See, female and male. See, then for this case, can you remember we handle that one? See, you know how this is. So you have that. See, Y bar would be, let's say that the salary or something. That's your response. See, Y bar for female, Y bar of the male. See, and in addition to that one, you have the overall mean. See, can you remember? You know how to get this done. See? And you are comparing this group to that group. Average of this one will be compared with that one. For this particular scenario, can I write a some kind of like a model for this one? I can write, no, I'm gonna get the like a some regardless of this one, for the given I group, I can get the jth observation, and for that one I can write the model. I'm not going to write the model over here, okay, because it's a very easy one. I'm not going to write that one later on, but I'm trying to show you that kind of a scenario. You are comparing average of this one to this one, and the multivariate case under this one, they're going to take into account that another two factors, variables. Two variables will be with the two variables. Here we have only one variable. See, salary only. See, for the female, salary only, male, salary only. Instead of that one, in multivariate case, let's say salary and GPA or something, salary and uh, monthly salary and annual income, something like that, annual income. See, you're going to add another one, annual income. See, now it becomes multivariate. That's what I'm trying to say. See, you're going to two for a female group, you check these two. Male group, you check these two groups, multivariate, become multivariate because you're not using one variable, two variable, but at the same time, they are averages. They are overall averages, vector averages will be compared. Monthly salary for the female to the monthly salary of that male and female compared. So does with the annual income. See, like that. So this is what multivariate. See? Not here. Not here. I have one factor still, one factor, two groups, two groups I can compare. More than that one, that's why we are heading towards now. That's called the analysis of variance or ANOVA. See, if you have two groups, it's like that. But see, now this multivariate, see? You can compare instead of that one, that one. That's what we are doing here in this case. See, this example, if you graphically represented that one, the example that we trying to over here, see, you have a two groups, see, you have a behavior modification group, cognitive group. Under that one, you are measuring two, SA and CSA, see. So if I draw this one, see, for that particular scenario, you have a one factor. See, one factor means, we can say the method. It has two layers. One is the behavior, see, modification, mod. The other one, cognitive. See, under that one, you're gonna find the reading for not only one variable. You have a two variable. One is client, SA. See, you measure two. See, client self-acceptance, client satisfaction. See, client satisfaction and client self-acceptance. See, these both you can tackle at the same time. That's called the multivariate. Multivariate, two groups. See? Two groups, one factor. If you have another factor, I'm going to have another axis like this. I'm going to get in over there pretty soon. See, like that. That's what I'm heading towards. See? At the same time, you can make a more, see, more levels. That's called ANOVA. So you have to get a clear idea. First, we have one. Now we have a two. Later on, go more than two. See, like more for given factor. And you can add more factors, more than one factor. we become two. We go to that in this class we're going to go to that actually the one factor, but I plan to go for that even the two for the see two factor. Another factor you can include this one. See, like a yield in a chemical reaction, yield here temperature here like a that some kind of a that uh, some uh, some what catalyst. You can use the catalyst, you can use the temperature, you get the yield. That you only one, two factors, but one. But instead of yield, you can think about another one, get it at the same time. Then multivariate. See, think about the get a clear idea. We don't have this factor yet. We have this scenario for time being. Only thing y has a two. That's why multivariate. If multivariate, how could we gonna tackle that one? Oh, no, we have that one. So let's keep going. See, that's the one that we calculated by. You don't have to do by hand. I show you that how they come up with that one. See, this one they call the within because of the multivariate. See, within means the sum of squared error, sum of squared, the sum of squares of the cross product, sum of squares of error and the cross product, both. Okay, this one. W1, W2. See, calculate. Similarly, W2 for this one. Then you pool it. See, you pool that one. Pool and then get that one t square. Bottom line, you are trying to get the n at the end of the day. Okay, so this one, see, then within sum of squares and cross product. See, W means a within sum of squares cross product or error sum of cross product. See? This one, the between one, I calculated that one too. See, then you get the overall one. See, you get the overall one for the one variable, second variable as well. Okay. And this is how this is the formula, how to get the between part. Between sum of squares. In the SAS we call the H. And we're going to add these two. And then I need the absolute value of this one, determinant. I need the determinant of within. Then I built up the Wilks lambda. See? Then with the aid of the Wilks lambda, you can get into the F in a different ways. We discussed that one too, see, different cases. Based on the case what you have, you set up. But if you don't fit in into any of these, fit in into this one. This is good. If you see the large sample, like more than 30, n more than 30, fitting into this one, you don't have to worry about this one. Even if it's not been displayed on that the printout, you don't have to worry about that one, and you can use this one. See? And related to that one, we talk about how to get the lambda in different ways. We talk about that one the other time. See? Then not only that one, not only Wilks lambda, Hotlin lowly trace. See, method 1, method 2, and the case one, how this will be related to F, to this one, and Pillai one. See, we don't have to calculate, but you know how I calculate, you don't do, but I showed over here for your convenience to make it get a confidence. Okay, whatever you see the results is same as what you see on that SAS output. Okay, you have to just run, see, this one, everything you can see. W, everything you can see. F, you can see. Wilks lambda, you can see. Lowly Hotlins, that Hotlins lowly, that Pillai Bartlett terror, actually trace. So Pillai Bartlett. See, this is the example for that particular example. Group. See, group has two levels. Can you remember? Group has two levels. Each one has a two variable. See, y1 and y2. I'm going to call them y1 and y2. That means in this one, I'm going to call this one y1, see, like a y1, this one y2, like that. How many groups I have? See, this one I'm going to call 1, this one I'm going to call 2, second group. See, so your readings are here. So for this guy, readings, see, under this one, for S and S, two reading sets, you're going to read like this. Here, two sets. Two sets for what? One for SA, the other one for CSA. Those are displayed over there. See? Like that. Why? I'm talking about the why. Okay. Can we write the model for this one? Yes. How could we get this all the expressions? Through the model. This all expression, this whole expression came through the model. You're gonna see this one. See this one. This formula came through the model. Okay. But even the two variable is not my major part, but it's a major part too. If you want, you can do that one. Two groups. You're going to compare two groups, one factor. Okay, I'm having one factor. I'm not going to compare the factors. I have a one factor. I compare the two groups. Within the two groups, I have a two variables. See, y1 and y2. This GP. Then once you run this one, that shows you get this guy. You get that one, which I have already derived by manually, and it's consistent. See. And this table is very consistent with what we have got over there. See, F value, numeric for this one. Then I just calculated, see, this one. Mainly Wilks lambda, we calculated by hand. See, I didn't calculate the rest. See, consistent, and F consistent. See, on the SAS, see, the code, see. One factor MANOVA, one factor GB, the two groups class 1 and 2 having two variable y and 1, 2 in each case. So you see this one class would be this one, your model. See, it's the same model. That's the same model. We know how to write this model. See, variable 1, variable 2, that's how you're going to feed into the SAS. See, group MANOVA, see, the group H should be printed, print E, print H. E is the same E that we see capital E. Okay, you saw here, see. E means like a within sum of squares, within sum of squares, and between sum of squares. This is H on the printout. This is E. Sorry, this one. See, we call that on W, but you know the SAS printout it's gonna show as a like a E. See, on graphically, program wise, matrix wise, see, we tackle everything. You should have that knowledge to explain to your audience at the end of the day graphically. See, look at what I'm doing over here. Follow very carefully. See, I tackle matrices too. I tackle the SAS program over here too. See, programming everything. Every aspect very important at the end of the day to that impress your client at the end of the day. See, they will be very, that you thoroughly know this stuff in every way. That's kind of a knowledge I really want you to build up. I'm not telling that you have to do that one all the time, but sometimes based on the different scenarios, you have to just write the program only. But it's not the case in some cases. Better off to know that what's going on behind is very important. See, it depends on that what you're trying to achieve. See, okay, this one, this part, okay. For that example, related to that example. So when it comes to the homework, that can we build up that kind of something like that? Let's say that let's pull out that homework related to if you do, we have something like that. See, look at the homework 3. What I did, I systematically add. See, I clean up. I get some variables. See, these variables related to that. I'm trying to get some factors. I'm trying to get some classes. Okay, groups. See, look at, I'm getting classes. I have income data. See, AK20, AK22 underscore P. Household total annual income of that public use file, the record. Okay, so based on that one, I classify that one. See, You have the numerical value, see, less than 2000, 26,000, you say 0 or low. And less than 5100, then see 1, 2, 3, like that. You can classify. See the classes. Income has a classes. Income is your what? Income is your level factor. That factor has a classes. Okay. I would prefer to call that one a factor. Okay. For a factor. A variable you can get underneath that one, the variable, but see this factor. And then see any variables and then make like a, that built up some kind of a scenario in which that you can easily utilize whatever we learn in this class. And then the way that I have done over here that related to this sedentary. Sedentary has been seen. I got that everything related to this one. See, average length of the time walk for transportation. The times walk at least 10 minutes for the leisure, past 7 days. See, those are average length of the time walk for the leisure. See, related to your all that exercises. See, at the same time, see, you are consuming that so much carb. That carb has to be that burn out at the end of the day because that's why you are working out. So how is going to affect to that your health? That kind of some kind of a scenario you can build up your own scenario. You don't have to stick to the what they have described on the that. That as an example, they have given something, but I'm building up this one. These all I got that one, and then even with that maximum is 0. If none of these, see, especially AD39W, 39 to 41 and 27, 41, 27, see, physical activity, walk at least that blah blah blah, which is E25. They did rigorous physical activity. See, out of these one, even for the maximum, if you get the 0, that means it's a sedentary, class sedentary. The other one, if it is not, it's called 0 and 1. One should be set. Sedentary is 1, and see, if this maximum is certain value, then you can say that one is active. Then you have a 2 classes. This is a factor. See, for the sedentary factor, you have like a 2 classes. One class, another class. See, same way here. See, for the gender, I'm going to call that one factor. That fact has a 2 variables. See, behavioral method, that's one. Here, female, male. Under that one, you can measure 2 at the same time. See, these 2 you measure. Those are the variables. Dependent variable. I would prefer to call that one dependent variable. Because of that reason, I'm going to call these ones, which are going to come on the x-axis. Always I'm going to call the factors. I don't like to call the variables. Factors. Factors, how many factors? For time being, we stick to the one factor. How many levels? Maybe 1 level, 2 level, 3 levels, like that. In this case, you have a 2 levels. See? Then we can check that one. See, we can check there. See, sedentary income and the income. Those. See, you see, 0 and 1 level, frequencies, percentages, income levels. See, this is a factor for this given this one. See, this one also factor income. So factor has a groups or classes or levels. 3 names you can use for this each one: level, group, class. This class, this group, or this level. For which one? For income. For this one, for what? Sedentary has two levels, 2 class, 2 groups. That's a factor. Another is factor. This one. See, it's another one. So then not only that one, then you can check the univariate AK22P. If you want, you can check that one. Then I parcel it. The data that we parcel, that the same kind of a data you can put together. You have like a same kind of a data. You can get the average of that one and build up distress and the worst. See, can you remember we did that one in homework number 1? Same thing I utilized. See, those data I'm going to utilize. and I can even fit in into the factor analysis too. And then mean of some of that similar kind of that data, I'm going to call another variable. I built up another variable. See how your mentality should be based on these variables. See variables that here. See A is 63, distress 12, distress 13. See, right? See all these I make like a one variable. See? One. Now, based on what I have in my hand, I try to play this one now. See, look at this one. See, see, sedentary would be my group. See, sedentary would be my group. It has how many levels? Two levels. Sorry, it has a two levels. It's being given by, see, not only one factor. This is very similar to what we are doing here. See? My factor is what? In that my homework, my factor, in this case, my factor is method. In homework, my factor is sedentary. Sedentary has two levels, 0 level and 1, sedentary or that active. Within that one, I'm trying to see measure two variables based on where active or not, based on two variables I'm trying to measure. Which two variables? The mentality, see, mental and BMI, body mass index. See, these are the two variables. This is exactly the same picture. See, one factor, two levels, and not only one variable you're going to measure, two variables you're going to measure, y1 and y2. If it's the case, see, you can set up like that. That's the same thing that we set up here. See, group has two levels. They have a two variable. How do you set this up? Sorry, see, variable, and group. Groups level will be split. Okay, they will take care once you give the data in this format, and then you use the maneuver HTTP like that in a similar fashion. So I'm gonna call here, see, the one way, one factor. I call the one way, one factor maneuver. Why maneuver? Because I'm using the more than one variable to be measured. Factor is sedentary with two groups, sedentary and active. We can say this one sedentary is, excuse me, one. The active is, see, 0. Having two variables, mental and BMI per in each group. Each group should have two. How do you set this up? See, I'm going to go to that data. See, it's the module. See, you already have data. So here, see, mental one is one, that one. You have the BMI, body mass index. See, BMIP is the body mass index. Recode, okay, and the maneuver. See, that one. So, not this one, not this one. Oh, here, this one. I'm sorry, this one. See, let's run. Test. See, go to this one. Set test to parser. This one is test. Okay, we put this one into test. Okay, it's in the test. So parser. Parcel one is utilize if you want. See, this one, this one, this one. Okay, then this one, I'm here. P-values. What are you going to compare? What are you going to compare? What are you going to compare? You're going to compare. What's your test? What would be your that test? Testing of hypothesis should be. See, that case, this one. You have one factor, see, one factor can give you a name, see. It has two levels, see, sedentary and active. This is 1, this is 0. But for Y, you're gonna have two readings, one for mental, the other one is body mass index. See? Then your H naught would be what? Vector of sedentary group H, sorry, with the active group versus they both not the same. Who's reading? The mental and BMI. See, mental and BMI. See, averages are not the same. See, they both can tackle at the same time. See? You can see whether that when you are doing when you be in the active, how it's going to affect your BMI and mental at the same time. See? And later on that you can go inside and then tackle that the variable as well. But these are the one that you're gonna check with the F, this F. F. And in addition to that one, you know how to get if you want, you can get it done by hand. You don't have to. You don't have to, because that's the same thing that I did over here. See, it's the same kind of example. See? Same kind of example. Two groups. See? Two groups. Same picture that I drew over here. See? The other page. You're going to compare these two. Mu of behavioral modification equals to the mu of cognitive versus they're not the same. That based on that method, which method would be better method, that you can check that one. See whether that this method would be the this one or this one with respect to this one in terms of these two. Okay, in terms of these given values. Okay, that's the idea. We're going to compare which method would be the better method. Okay, we're going to go to more example and then come back and forth and then see. Okay, so related to that theory up to that point. See, now see this one, that's the same thing. I talk about y1, y2. See, they are that one. That's good. Everything we talk about that one. Okay, look at here. This is the key part. Okay, this is same as that what we are having at that our homework. Okay, see here. So, yeah, this one related to same as that. This is that one factor. Factor has a two level. These are the two variables. Okay, two variables. We're gonna tackle at the same time. Look at that our discussion here. This is same kind of a thing in that related to that behavioral modification and cognitive method. Okay, now see here. Since p-value 0.015 less than 0.05 level of significance, we reject H naught. That means there are no mean differences between the behavior modification and cognitive groups. Between those groups when they are compared simultaneously on what? These two variables. See? Make sure you write very clearly. You have to write like that. Based on that one, you're going to compare contrast the two levels of that particular factor. But with regard to what? Simultaneously comparing, you are not comparing two groups, you are comparing the two variables at the end of the day. See? You can see client self and the client satisfaction. Both based on that. See? They both see? See? So you have to say that there are no differences because you reject H naught. Reject H naught. H naught is such that there are no mean differences between that means this one mu of behavioral modification BM see, equals to see, cognitive. See, versus its counterpart. You know that mu behavioral modification, that method. See, no mean differences. Mean differences. See, difference means like if you're gonna take to the other side, you can take the difference. No mean difference because you reject H naught. You reject H this one. See, there's no mean. See, that one being rejected. See, there's no mean differences being rejected. There are mean differences with regard to what? With regard to that when you when they are compared simultaneously with on these two variables. Remember, the variables are the key part. Based on these two variables, see, these two variables in that homework, based on these two variables, see, you can write the same. You can build up. See. Then, after finding that the groups differ, we would like groups, the classes differ. We would like to determine which of the variables now, SAO and CN, are contributing to the overall difference. Now we're going to have a look at it, the variables. First, you looking into that levels, and inside the level, there are two variables. We don't know which variable is contributing for this overall difference. They are difference. Average of this group coming from this one and that one, when they are compared simultaneously with regard to these two variables, are different. That difference are due to which variable is the next step. It's called a post hoc. That means right after you're done with the test, you have to go move that, do the comparison. See, now between this one and variable, see, contributing to overall post hoc procedures, such as two keys. You can use the two keys. In univariate ANOVA, see, we determine which group contribute to the overall difference. See, you can see univariate ANOVA even being displayed when you run that one. In multivariate ANOVA, we determine which variable contribute to the overall, sorry, which in univariate ANOVA, we determine which groups, see, univariate ANOVA, which groups contribute to the overall difference. But in multivariate ANOVA, we don't go to the groups. They were groups, but you go inside the variable contributed to them. You have to go to this one. You have to make sure which variable is contributing to our difference in the overall difference at the end of the day. See, then we do the univariate ANOVA for this one and this one separately. See, univariate ANOVA. GP1, behavioral modification and cognitive. In our homework, the homework that right now I'm going through, you're going to do that one for the mental, the sedentary and active. See those two groups. See, look at that. I'm taking that difference. Univariate ANOVA, you're going to tackle that one. See, they have a table. So, okay, you don't have to do that one. Table will be displayed over here. See. See, mu1 to mu1. See, you're gonna check that. This is what? This is what the y variable, see? The one variable in the group one. For the group one, you're gonna compare this one. See? For the dependent variable y1, you have this. Okay, so that when you run that one, see, you get the univariate table as well. Okay, if I go to, I'm talking about the two things under this multivariate. Multivariate. Yeah, under multivariate, yeah, two classes, CSV, is the right example. We don't have a CSV group. one factor, okay. GP with two groups, 1 and 2, and two variables, okay. That this one, 193, yeah, this one, no. So you have a one factor. What is the factor over here? I'm gonna say student. One factor, one group means one factor. GP, three groups. That have a three groups. Example. I'm talking about this example. I'm still on this example. This one. This example. You have a T. Seriously, there is that one. That's what I want to know. On SAS. Not that one. Is that the one? 936297. 9362. No, not that one. Okay. This one, where is that one? Okay, let's. Where is that one? No. This one. This one. Two class having no variables. One way factor. One factor group. 1337. 133722. Yeah, that's the one. So I had to little bit clean up this one. One 133722. The second group, see 466868. Okay, this one. Okay, then what I'm trying to say, see, I'm gonna little bit clean up this one. Okay. So one way, one factor, not GP, is the factor is this one two, this one two classes. One is equals one, two equals one and two. Two, we call that one two. Group two, we can call that no, this one is not that one. No, I think I'm mixing up this one. This one is SA and CSA. It's not the sedentary one. Sedentary one in our example. Okay. Second. This one group. Say the method. I can say method, not the sedentary. Sorry. This one sedentary. This one. One stand for behavior modification. Second stand for cognitive. Okay, that's right. Having two variables, one is SA, one equals SA, the other one is CSA. Client satisfaction. like that. That's what I will say. Here, here. So when they see, when they run, you have a univariate ones. By looking at the univariate ones, see, you can see univariate. See, see, this for the y2 univariate ANOVA table. This is the y1. That's the one that I'm talking about here. Okay, to check that which variable will contribute overall that differences at the end of the day. Which variable, SA or CSA. That's what we are trying to figure out. Okay. See, for that one, you're gonna looking into the univariate ones. See, see, the new one. See, so you have a behavioral modification and this one. See, new one being compared between. See, new one being compared between these two groups. See, within the group, but the new one. See, new one. Y1 and Y2 for the group one. See, see. So, see. And then the since p-value, this one level, we reject H0 and infer that group differences are present for outcome variable y1. That means outcome variable y1 contribute to the overall mean difference between two groups. See, see, look at it. That's the final that decision. Since p-value from the univariate case, see, from the univariate, see, we reject H0 and infer that the group differences are present. Okay. Therefore, outcome variable y1, see, contribute to the see, y1. This is related to the y1. See, see, y1. I'm sorry. This one is this is y1 related to y1 in two groups. You're gonna compare y1 in two groups. Okay. Behave this one and this one. See, mu1 and mu2. Then this should be y. Oh, no. This is not the. It should be YG. Oh, not the group one. There should be for Y1. For Y1, I'm gonna check this one in behavioral group modification and cognitive one. See, this one the same thing. For what? Y2. See, Y2 behavioral one and cognitive. See, this is for Y1. Y1. This is for Y2. It should be not this one. See, that's the comparison. You're gonna do the comparison of the variable between those groups and see if there's a significance. See, there's a significance. The second one, look at this one. See, since p-value 0.02 less than this one level, we reject H0 and infer that group difference are present. Contribute to the overall mean difference between two groups to this one. See, so this one here 0.025 both. See, outcome variable y1 contribute to the overall mean differences. Then second one you're gonna go to and then check that for the mu2 in these two groups. See? That means this variable y2, and then still you can say both variables are contributing to the overall differences. So you know that's why you cannot simply go by the level. You cannot simply go by the the VMOC, that one level. You have to make sure that you get the readings, see, based on that variables, how the variable gonna behave. See, which variable will contribute. That's the key part in MANOVA. Okay, MANOVA, you check the variables, not the levels, not the levels, not the groups. Okay, not the levels. See, not the levels. See, not levels, not groups, not groups, not classes. You're not gonna compare the class. You're looking for what? You're looking for what variable. Okay, which variable contribute. That's the idea. Okay, so these numbers, how they come, that you can figure out that one. We looking into that one. The same way that if you go to that related to the homework, you can build up the way that I said this up. I'm sorry that see, related to this one, you can build up that one and say which variable, mental or BMI, would contribute to the overall differences. First, you're going to check whether there are any difference between the sedentary and active levels. Two levels, see these two levels. And if you're going to write that you have that hypothesis for that one, okay? When it's the same like over here, see, up to here. See, this discussion should come up to here because it's lengthy, because I have added that by hand I have done, but you don't have to do that one. But this discussion should be there. Okay, we should straight go to the printout. See, you're gonna start from here. See, you have to do from here. Then you write. And this one, go to here, go to the overall one and make a conclusion. Come to the univariate one, make a conclusion. That's it. Okay. Here, and say there are no differences between that in that homework one, that the sedentary and that active two levels. And then when they were compared, when we are measuring that two variables, the mental and then BMI, that variables measurements are taken. Now you want to see mental or BMI would contribute to these differences if there are any differences between two groups, okay, in their readings. Okay, you have to go to the variables. Okay. So, but this one so lengthy because that we have added all the techniques that come to that one. But you go further down a little bit. Okay, I'm gonna go further down a little bit. See, look at what I'm gonna do. One factor, but you have three or more groups now. See, more groups. One factor, more groups. See, one way is called the one way what? One way ANOVA. See, more than two groups. See, it's a univariate case. One variable per group. See, you have done that univariate analysis of variance. See, and this is this is how they're gonna set up. See, this mu1 in the first group, second group. See, factor. Okay, one factor, you have one factor still. One factor. I prefer to call this one variable. I prefer to call this one factor. I prefer to call these ones groups or levels or classes. Try to understand. Don't mix them up. Okay, so if the discussion get messed up, that if you use the different words for different places. This is a factor. Whatever the factor, like a gender, different one, income. More than one level, we have one level, second level, the medium, high, low, like that. See, three levels. So see, they are average. Whose averages? I'm talking about this guy average, okay? Response variables average. For this given income levels, you can check something, okay? In that, okay? That one. So that's my ANOVA. It is customary to regard mu I, mean the ith population group, see this group mu I, as the sum of an overall mean, component, and see, and the treatment effect. This is the model. This is how the model comes into the picture. The mean of the ith group is nothing but overall mean by the ith impact coming from that one. See, because of that, instead of that one, you can write, you have done this one, okay? Univariate case you have done. Instead of that one, you can say they are equivalent to same. You can say there's no treatment effects, go to zero. When you go to the analysis of variance in this means model, you can say Yij, say look at the Yij equals to, you have a group here, you have a response here, plus mu I plus this difference is epsilon. That's the error. This model, if you can write the reading like this, for I stand for given, I means that which group would that be? J would be which observation, see, observation. Different group has a different observation. We talk about, see, different groups, different class of different observation, number of observations. O, there's a second one, effects model. Mu I can be replaced by this one, see, treatment effects. either this way. Yij you can write this way. Grand mean plus treatment effects epsilon. And see in the picture, see the treatment that part mu plus this plus error is Yij. That's the case. See, motivated by this one, by above model, the analysis of variance is based upon the analogous decomposition of the observation. Given observation, you're gonna write this one now. I'm gonna write this one given observation. Look at it. Instead of Yij, I'm gonna write Yij in sample case. Instead of mu, I'm gonna write y bar. Okay. Instead of tau, mu I minus mu, I'm gonna write yi minus y bar. This one, Yij, Yij minus mu y. Mu y means what? Y bar. See, that's mean. That's how you get this one to that side, and you're gonna square and then sum them up. That's how you got this sum of square treatment and sum of square treatment total residual like that. See, this one you have already done. See? Total sum of square, total sum of square treatment. How did you get that one? With the aid of the model and with the aid of the observation. In the model, you have the population setting, two settings, effects model and the means model. I'm using the effects model. See, I'm using this model. Grand mean will be replaced by its counterpart. This part will be replaced by this guy. See, but in sample version, it's going to be y bar I minus grand mean y bar. And this part will be replaced by Yij minus mu I. There's no mu I in sample. You have y bar, its counterpart. So this is the error estimation. This is the treatment effect. This is a grand mean. And this one, I'm going to take the grand mean to the other side and then square and then sum them up over what? Over number of levels and number of observations per each group. So that's the one we put in into the table. See their degrees of freedom being given. Then you can build up their means, see, mean squares. And then from that one, you can build up the F distribution. That's not what I'm interested in. This is the one I'm interested in. Instead of that one, I'm going to go to the multivariate case. We still have one factor. That factor has several classes, several groups. If that's the case, but how many variables? More than one variable per group. See? These are the variables. How many variables I'm interested in? T variables. T variables. These are vectors. Same thing. Whatever I did over here, instead of using scalars, I'm using vectors to say this story. Same thing, okay? Because I'm using not one variable, I'm using several variables. In this case, you are using one factor, three or more groups, but one variable. Here, I'm using many variables at the same time. That's why it becomes multivariate. That's called MANOVA. G groups, MANOVA. See? See? But you have on Y, you have how many variables you're supposed to read. On here, you're supposed to read P many variables. See? Instead of that one, you can write that one with the aid of the effects model. See? And no effects, and versus it at least one of them equal to 0 like that. Okay. Like that. And again, see, it's the model. It's the effects model. Now go with the vectors. See? And then motivated by this one, I'm going to write that one with the aid of same thing. I'm write the vectors. That's it. So instead of one variable, you have several variables. See? And I get to this side, you cannot square. In this case, you cannot square. You have to get the transpose. That's it. Square is given by transpose. Normally, you in the univariate case, you square here. Square means split because you are dealing with the vectors and matrices. See? You don't do anything. I'm just showing you. See, this is same thing we call the B plus W, H plus C. That in SAS output, you see this one. Their treatment, their degrees of freedom, the same thing. See? Then you're gonna write the Wilks lambda. You don't go to F right away. You cannot go. You have to go to Wilks lambda, is this one. Okay. Wilks lambda and other important statistics such as Hotlin, Lowry, tree split, tree, Roy, maximum, blah, blah, already been given. We discussed that one, even repeated measures, right there. Let's look at this example. See, one way, three groups, class, okay, three classes, ANOVA, sorry, ANOVA example. See, this is the ANOVA example, then go to the ANOVA example. This ANOVA, okay, one variable. See, ANOVA example, okay. Three group of 1, 2, 3. See, you calculate. This one thing under that one. See, I calculated this one, and I did that like that. Then for each and every reading, you have to calculate this one. Treatment, this is a total, this is a treatment, residual. ANOVA table looks like this way, okay? And degrees of freedom look like this way. That's the same example we were trying. See, 191619202223 see? This is the data. First population has a 969. Second population has a 0 and 2. See? So we're not going to use MANOVA, we use ANOVA. See? Input, group, and Y, one variable. See, one variable. First group has a 3. That group has a 3 layers, 3 levels, 3 groups. 969. Okay? 969, 969, 02312, 02, 0252. I'm using the ANOVA. Class is group, model is this one. If you run, you get the same answer that we got it from that one. You don't use the MANOVA because it's a univariate case. See? See, one way ANOVA, one factor, GPV, 3 groups, classes 1, 2, 3, having each variable in group class, one variable. See? ANOVA table, you don't have Wilks. See? This one. See? If you want, you can go to this one. If you want, you can go to that critical value and compare and contrast it. See? And with that one, see, 950. See? 950 here. I'm sorry, 1950, 19.50. And I'm going to check with their degrees of freedom 2 and 5. Okay? And see what's the corresponding that p-value for that one. If you want, you can check that one too. You don't have to see 0.004. That's what we had over here. When we run this one, do you get that one? See, 0.0044. Then that for that example, but this is the most important example. One way, 3 groups, 3 class, but MANOVA, excuse me, with 3 variables per group, 3 variables per group, okay? The research assigned 33 subjects to one of the 3 groups. We did that one the other day. The first group received technical dietary information in this one. I'm gonna just a little bit do this one, and I'm gonna stop over here because I had to jump into the other class. We can continue this same discussion tomorrow. See? So related to this one, see, this MANOVA. Okay, one way means one factor. You have a one factor, but that factor has a 3 groups. Okay, but each group has a 3 variables. That's the idea. See, sample a research assigned 33 subject to N is 33. The first group received technical data. See, this one, in, how the presentation is done, no information being delivered, that would be your factor. How the one is given by the, see, you go to online, and the other one given by the nurse practitioner give that one, nurse, the third one given by the video. See, and you're going to do the ratings for three variables: difficulty, importance, and usefulness. Difficulty, usefulness, and importance. These 3. This is the way how you that one. I get that one data. I uploaded to that one. See, one way maneuver, one factor, dietary information receiving method. I'm gonna call that one with uh, it's not right. With three group of classes: website, nurse, and video, having three variables as well. Having three variables, useful, difficulty in each group class. So data multivariate, set up this one. This is the way how that works. Useful, difficulty, the variable. See, is your group. Group has a how many variable, how many groups? Group means that factor. Okay, this is the factor. I prefer to call this a factor. I'm using maneuver. And then once you use that one, you get this information. See, from then all kind of stuff. Then since we have three groups, you cannot say that which if you reject H naught, you cannot just simply say that one group is better. No, there's no such discussion. Then you have to go to multiple comparison. Okay, because there's more than two groups. More than two groups, one factor. See? One factor with three. See, with three groups, website, now having three variables, useful, difficulty in each group for class. Yeah, see. Again, see, again that you can, if you reject that one, again that you can go to each one and then compare and two at a time and see which one contribute. Okay, and you can do two cannot remember, then you're going to go to the variable. Now variable in, see, variable compare with what? Two at a time, not three. Two at a time. Okay, variables then compare. That's the way that we did earlier. See, when in this one you have a three groups, but you're going to compare the variables, one variable from this group with the variable from the second group, compare, and the second variable with this one and compare with that one, and then how they are contributed, and then they can do the multiple comparison right there. Okay, multiple comparison. Okay, we can talk about that one tomorrow. Okay, so that one. Okay, so related to that one, if you see something related to that one, do we see something related to that one on our this one? Okay. This one here, this one here. Look at it. What is this one? See, the gender. See here, two-way. No, this is a two-way one because that's the one I'm heading towards right now. Okay, I go see. We did this example. As an example that if you're gonna get it done by hand, see, you're gonna come by same thing. See, one way, three groups, cars, maneuver. Example, see, I did by hand too. You don't have to do by hand. See, I did by hand for you to see, compare and contrast how they were working behind that one. Get a clear idea. See, built up this one. You can see these ones. Their information. And the Wilks lambda we compare, see, will be built up by hand. See? And that one can be related to what? F like this. And then see, we can reject H node. See? That's the same thing. This one. Now we come to the two factors. Look at what I'm going to do. Two factors. Okay. I'm going to just little bit, I'm going to go through this one tomorrow. This for the homework, I'm trying to get one like that one too. Here, look at. See, that's it. See, that's this one. That's it. You don't have to do too much on that one. Just I want to see that how your knowledge being built up on this one. See, you have a two variables. See, two variables here. Variable two. You have a how many? See, sedentary. Sedentary has two factors. Okay, you know that one. That's a factor. Has a two levels. This is a second factor now. Has a two levels. Is two variable, two factors, and two variables, two factors, and two levels for each group. See, that's what we are trying to talk about here. See, the factor one, factor two. Factor one has how many levels? 1 through G in my example, in a homework example, or whatever the example I'm trying to take over here. See, I'm gonna say this one. See water, how that water would be. We're gonna put the water daily, or that a certain example weekly, and then their sunlight at the height. See, see, these are the two factors. The water, how water means that factor has a two levels, daily and weekly. See, daily and weekly. Sunlight has a two levels, low, sorry, three levels, low, medium, and high. See? Variable has only one variable. It's ANOVA. It's ANOVA. See, it's a two-way ANOVA. Two-way ANOVA example. See? It's a two-way ANOVA example. That's one of it. See, and this one MANOVA, same thing. That's what I'm trying to show over here. See, once you do this one, the MANOVA is the example that something that we have to talk about in our homework. Right? So here, from starting from here, okay. Two groups, they built up like this. They have a now factor one, factor two, interaction term, something called interaction term, and residual. Okay? It's like this. You don't have to worry about this one. Okay. So you have a sum of square total, sum of square factor, sum of square factor two, interaction and residual. So their degrees of freedom are given. And once you that how they are related to F being given. And in this particular example, see, factor one, factor two, variable one. So that one. Okay. And by looking at the different interaction term, if you want to check that whether interaction term is important or not. See, look at this one. Sorry, p value.
How do we tell which interaction is better?
No, there's only one interaction. See.
Oh, okay. Oh, the water terms.
Under the interaction, oh yeah, I know what you mean. You were thinking of under the levels, see, levels.
Yeah, under the level, how
level.
do we?
Yeah, when you go to the interaction, and that's what I'm telling you, don't go to level, go to these two.
Okay.
Go to the factors, interaction between not the variables, okay? Factors, see, factors, but factors have a levels.
Okay.
All should be taken into account when you make the overall decision at the end of the day. Okay. But again, if you say that, let's say that if you go back to the because you have a two factors, see, then this factor, see, this is a factor. Whether this factor is important, to what? To explain this what? This the growth of, let's say some growth of like a tree or something like that. See,
okay,
the sunlight, and you're gonna check that whether the growth of that particular tree. See,
okay,
be effect to that one. How which one gonna be effect to that one? See? Interaction would be important or not? That kind of a discussion.
Okay.
And their counterparties, you're not gonna go to one variable. You go to more than variable, but you see, look at. You have a factor here, response, not only one, several responses. That's why I say more than one variable. See, now you use the vectors and matrices. Once you come to that one, the same thing, okay, you can have a look at it. See, You can say this test interaction term rejected if this chi-squared is greater than that one, where lambda is this much. See? Do we have these lambdas in our table? Yes, we don't calculate this one. When you run that one, see? Example, look at this one. So I'm real quick gonna go this one, and we're gonna go through this one again that tomorrow very slowly and steadily. See? The optimal say condition for the say, extruding plastic film have been examined using a technique called the evolutionary operation. In this course of this study, three responses. See, look at the variables. See, tear resistance, gloss, and opacity were measured at two levels of factors. What are the two factors? Rate of extrusion and amount of an additive. And how many measurements? 5. When you are talking about 2, see, this is the data. Factor 1, amount of additive. And then factor 2, change in rate of extrusion. And factor 1 has 2 levels. Factor 2 has a 2 level. No, I'm sorry, factor 1, this should be factor 2. Okay, I made a mistake here. Factor 2 is a factor 1. Okay, and it has a 2 levels, but you are make the readings for 3 variables. What are those? See, tear resistance, gloss, and opacity. See, look at the reading. You tackle this one, all these. See, once you tackle, you get these readings. See? Residual and then total come like a matrices. See, sum of squared, cross product. Sum of squared, product, cross product for the factor 1. Sum of squared cross product for factor 1, sum of squared cross product for factor 2, sum of squared cross product for interaction, sum of squared and cross product for residual, total, everything. See? From there you can build up the lambdas, everything. But what I'm trying to say on the that data, when you're going to enter into data, see, you see, this is your factor. Factor is a categorical that I put a dollar sign after that one. This is second factor. Factor 1, factor 2. Not one variable, 3 variables. That variable, that data were nicely laid out over here. Then you use what? Class. Class means your 2 factors. Model means variable, variable. See? Factor, the other factor and interaction as well. And then whatever you want, you can say if you want all, you can get the all. See? Like that. But I'm gonna go through that one now. I show you here. See? It's related to even the same. That's the same thing I'm talking about. See, look at that. Let's say the BMI. I'm looking for 2 variables at the same time, not one variable, because of this one multivariate. What are the factors? Income, sedentary, see, the gender. If you want, you can go to the interaction. If you want interaction between these two, or interaction between these two, and interaction between all, you can include it. And you can get the contrast as well. But mainly that come to this one, look at here, 2 of them, see, 2 factors, see, sedentary, gender, see, then mental and BMI. Their readings come in reparatory, okay? Readings are, there are so many readings because that we have 14,000 or something like that, see, mental, see, variable, 2 variables measured within this factor, which has 2 levels, 0 and 1, and another factor, this one completely fitting into the picture that I have drawn over here. Sorry. This one, this is what I'm talking, this one. That's the one, 2A ANOVA, 2A MANOVA, 2A MANOVA. It's a factor 1. Sedentary, how many levels? 2 levels, that's okay, that's fine. 2 levels, active, sedentary. The other one, gender, male, female. And for them, we're going to measure 2 things, not one variable. Response variable has a 2. Mental and BMI. How could 2 tackle? You data enter like this. or the way that we have over there already. And you're going to write the model. This is the important part. In the data over there, already data there. So this part. Write this and run, and then discuss that one. That's all that we are planning to do in this under the multivariate case. Multivariate case. If you summarize what I did, you have one group, sorry, one factor. You have a two factors, you have a three factors. Sorry, two factors. You have one factor. I'm sorry. What I did, you have in the beginning one group, one variable. Then later on, two groups or two variable, two groups. Okay, two groups, several variables, two groups, several variables. The MANOVA and ANOVA is the MANOVA part. When it's come to the one-way MANOVA means one factor, you have like a several groups and several variables. Two-factor MANOVA means you have a two factors. Each factor has like a several levels. At the same time, for the response, you're not going to measure only one response, several responses. That's the key part. Those are the ones that we have set up. Mainly those are the ones that we were trying to tackle over here in this homework. Okay. So we can continue the same discussion. I'm not going to do anything more than that. Everything will be revolve around this note, and then our homework, and then other examples. That's it. See, so homework is this much. That's it. And we can find the compare and contrast and all these things too for that one too, and to keep post hoc one. See, if you want, you can do that one. Look at here. See, so if you want the Tuki, that two at a time, that see, comparison, multiple comparison. Sedentary, this one. See, how many factors? Income has a like, can you remember? Income has a several levels, several groups. Sedentary has a several groups. Gender has a two groups, but do not measure that one. If you measure one, it becomes not MANOVA, it becomes ANOVA. Two-way ANOVA. This become what? Three-way ANOVA. See, 1, 2, 3. Three-way MANOVA. 1, 2, 3. Three-way. Because of this more than two variables, we call MANOVA. Okay. So this one, see, this one is just like a one. Okay, here, look at the two-way MANOVA. This is what? See, this is just like a see. So you have one variable, one group. Within the group, see, you have a two variable. You're gonna compare those. This is like a two groups. It's a two groups. It's a one, two. See, two groups. You have a two groups. If something has a more than two levels, that example we had in the multivariate case, this one. So what I'm gonna do tomorrow again, that we go through this one and nicely going clear that all the cases, and then we can finish on that one. Okay. I'm gonna just stop over here because I had to jump into the other class. That do you guys have any question? If not, I'm gonna just let you go. That you have a good night and see you tomorrow, and then have a good night. Okay, then stay safe and be well. Okay, take care.
Thank you. Have a good night.
Have a good night. Take care. Bye. Good night. Take care.